So this is 2.6/2.7, but we are just graphing. Cheat sheet's super helpful when doing your homework, but you do not get it on the test, so make sure you know everything from this cheat sheet. So it helps you to find the domain, vertical, horizontal asymptotes, slant asymptotes, x and y intercepts, and the holes. So when graphing, we're going to follow these steps. This is a strategy for graphing rational functions. So the first thing we want to do is find the x and y intercepts. How do I find the x-intercept? What does my cheat sheet say? We set the numerator equal to 0. What about the y-intercept? So we plug in 0 for x. We want to see if we have any vertical asymptotes, horizontal asymptotes, and then we want to plot at least one point between and beyond each x-intercept and vertical asymptote. How would I plot points? What do you think? We can just pick values for x, plug them in, and that'll give us a point once we get the y. So we can just pick whatever number we want. So we want to first plot our x and y intercepts, vertical, horizontal asymptotes. If we have a slant asymptote, we want to put that too. And then pick a point in between each one of those to see what our graph is going to do. Remember, our parent function of rational graphs has this boomerang type shape. But it'll hug wherever our asymptotes are. So as our asymptotes get closer to infinity, the graph gets closer to the asymptote. So it hugs the corner in there. Do you think my graph could have this type of shape? Why not? This is not a function because if I did the vertical line test, it touches at 2 points, so that would be not a function. So all of these are rational functions. They are functions. So if you have a line on top of another line, you did something wrong. So let's get into graphing. So we want to start by finding our x and y intercepts. So let's find the x-intercept first. How do I find the x-intercept? Set the numerator equal to 0. Because if the numerator is 0, my whole function is 0. So I really only care about the numerator. So I set the numerator equal to 0. So 5x is equal to 0. Divide by 5, so x is equal to 0. So what would my point be here? If I got x is equal to 0, that means my x is 0. What's y? 0. Because I set this equal to 0, that means y is 0. So my first point is at 0, 0. Now let's find my y-intercept. How do I find the y-intercept? Plug in 0 into all my x's. So I have 5 times 0 and 0 minus 2. So this would be 0 over negative 2. And what's 0 over negative 2? 0. So what's my point for my y-intercept? 0, 0. So that is the same point. So I didn't really give us much information, but it's okay. Next, let's find our vertical asymptotes. How do I find the vertical asymptotes? We set the bottom equal to 0 because it's going to be a line, so it'll be x equals. So we set the denominator equal to 0. So I have x minus 2 is equal to 0. Add 2 to both sides, so x is equal to 2. So that's my vertical asymptote. Do vertical lines go up and down or sideways? Up and down. So I have a line going up and down through 2. There's my vertical asymptote. How do I find my horizontal asymptote? Awesome. I'm looking at the degrees of my leading terms for the numerator and the denominator. So it's just x to the first power and x to the first power. So when they're the same, we look at the coefficients. So this would be y is equal to 5 over 1. And what's 5 over 1? Just 5. So y is equal to 5 is our horizontal asymptote. So through 5, I have a horizontal line. Now these are just asymptotes. They're not part of our graph. They help us graph, so we need them there. But they're dotted lines because they're not actually part of our function. So once we have found our x, y-intercepts, our vertical asymptote, horizontal asymptote, now we need to plug in points to see where our graph is going to be. So I want to plug in points in between every vertical asymptote. So I need to plug in some points over here and some points over here. So what's the number I could plug in to start? We have many, many options. 4. So we're going to plug in a point on the right side. So let's plug in 4. I'm plugging it into my x and solving for y. So I have 5 times 4 over 4 minus 2. So this would be 20 over 2, which is 10. So what's my point here? 4 comma 10. Because I plugged in 4 for x and I got 10 for y. So I'm going to go to the right 4 and up 10, which would be off our graph up here. What's another point I could plug in? I'm going to stick to, since we did something on the right side, I'm going to plug in another point on the right side just so we can finish that part of our graph. But we could plug in 5 or 6. Just something that'll show us the shape of whatever our graph is doing up here in that quadrant. So I'm going to plug in 6. So I have 5 times 6 over 6 minus 2. So 30 over 4, which is about what? 7.5-ish. So what would my point be? 6 comma 7.5. So I'm going to go to the right 6 and up 7.5 there. So you could plug in as many points as you want. I would say plug in 2 from each side. Our graph is never going to cross the vertical asymptote. So our vertical asymptote keeps going up to infinity. So we never cross the vertical asymptotes. We can sometimes cross the horizontal asymptotes, but it's going to be close to 0. So sometimes we may cross, but here we're not going to. As we go out to infinity, we get really, really close to our asymptotes, but we don't cross them. So our graph will look like this. So it's always going to hug the corner. It looks like a boomerang. If you want to plug in more points to help you find the shape, plug in as many points as you want. We really only need 2 from each part to see what you're going to do. So that's our right side of our vertical asymptote. Now let's figure out the left. So our graph is either going to be up top in the left or down below on the left. We have a point already, so we know it's going to be down below here, but let's plug in a couple more points to see the shape. So what's another number I can plug in? Sure, let's plug in 1. So I have 5 times 1 over 1 minus 2. So 5 over negative 1, which is negative 5. So what would my point be here? 1 comma negative 5. So I'm going to go to the right 1 and down to negative 5. And then let's pick another point to plug in. Any other number from the left side? Negative 1, sure. So I have 5 times -1 over -1 minus 2. So this would be -5 over -3, which would be about what? How can I figure out how to graph a fraction? What can I do? I can divide it and make it a decimal to see. It doesn't have to be exact, but you want to know an idea of what this is going to be. So it's going to be positive. And then 3 goes into 5 one time with 2 left over. So it'd be like 1 2/3-ish. Or you could say like 1.6-ish. So again, it doesn't have to be exact. We just need an idea of where it's going to be. So 1.6-ish. So what would my point be? -1, 1.6. So I'm going to go to the left to -1 and up 1.6. Bless you. So again, we can keep plugging in as many numbers as we want. I would say if we have a point here and here, maybe plug in something that's like further away from our vertical asymptote so we would get an idea of what it's going to do up here. But once we have 3 points, we can tell the shape. It's going to boomerang and hug the corner there. And as our asymptotes get closer to infinity, our graph gets closer to the asymptote. So we are going to get really, really close to the asymptote as we go out here. Same thing. We're going to get closer to the asymptote as we go down here. Yes?
Do you just pick?
All right, so again, we are graphing. We're going to do the same things we did in the last one. So how can I find my x-intercept? Set the numerator equal to 0. So I'm going to solve. I have 2x squared is equal to 0. Divide by 2. So x squared is equal to 0. Take the square root. So x is equal to 0. So what would my point be for the x-intercept? 0, 0. So in your x-intercept, your y is always going to be 0. And then whatever value we get when we set the numerator equal to 0, that will be your x value because it's the x-intercept. That will be the one with the number. So our point is 0, 0. We can go ahead and graph that. How do I find the y-intercept? Plug in 0 for x. So I have 2 times 0 squared over 0 minus 25, which would be 0 over -25. And what's 0 over -25? 0. So my y-intercept is 0, 0. So again, that doesn't give us much information to the same point. So doing that, we only get 1 point, which is fine. Next, let's find our vertical asymptote. How do I find the vertical asymptote? Set the denominator equal to 0. And we solve. So I have x squared minus 25 is equal to 0. Add 25 to both sides, so x squared is equal to 25. Take the square root. So what does x equal? Plus or minus 5. Awesome. Anytime you take the square root of both sides, you need that plus or minus. So I have 2 vertical asymptotes. I have x is equal to 5 and x is equal to -5. So I'm going to graph my 2 vertical asymptotes. And then lastly, I need my horizontal asymptote. How do I find the horizontal asymptote? I look at the degrees of my leading term in the numerator and the denominator. What happens if they're the same? I use the coefficients. So this would be y is equal to 2 over 1. And what's 2 over 1? 2. So y is equal to 2 is my horizontal asymptote. So I'm going to put a horizontal line through 2. So what's the number we want to plug in? Sure. Let's plug in 6. So 6, we're going to start on the right side. We're going to figure out what our graph is doing over here on the right side. So let's plug in 6. I have 2 times 6 squared over 6 squared minus 25. Bless you. So this would be 72 over 36 minus 25, which is 11. How do I know what 72 over 11 is?
66 divided by 11 is 6, and the remainder is...
So let's just say, remember, it doesn't have to be exact. It just has to give us an idea. We know 11 goes into 72 6 times, 6 and some. I could say like 6.5-ish, or I could say just 6-ish. So what did I plug in for x? 6, and I got 6.5. So I'm going to go to the right to 6 and up 6.5. So if you get fractions, just make it a decimal to see where you're going to be on the graph. So that gave us 1 point on the right side. Let's plug in another point to see what we're going to do.
Could we just, like, make it a mixed number also?
Yeah. No, you can make it a mixed number, whatever you need to do to graph it. On the right side. So we want to finish over here. We don't just want to plug in like a random point here, here, and here. Like, let's finish one part, graph it, then we can move on. Sure. Let's plug in 8. So I have 2 times 8 squared over 8 squared minus 25. So 8 squared is 64 times 2 would be 128. 64 minus 25 would be 39. Yeah. So what's 28 divided by 39? 3-ish. Because 39 is like 40, and 120 divided by 40 would be like 3. So if you need to, write it down, divide. But remember, we're just approximating. It doesn't have to be exact because we just need a point on our graph to see what it's going to do. So we have 3-ish. So I plugged in 8 and got 3. So I'm going to go to the right 8 and up 3-ish. We only need 2 points to see what our graph's going to do. We know we're in the upper right quadrant, and it's going to hug the corner there. As our graph gets closer to infinity, we're going to get closer to the asymptote. But we don't cross the asymptote. So our graph is always going to get close to the asymptote here and here. All right, let's work with the middle part now. So I already have a point. We want to plug in some number to the left of our x-intercept and some point to the right of it. So we need some number in between -1 and -4, and some number in between +1 and +4. So what can we plug in? Sure, let's do -3. So 2 times -3 squared over -3 squared minus 25. So 2 times 9 would be 18, and then 9 minus 25 would be -16. So this would be -1-ish. So I plugged in -3 and got -1-ish. So on my graph, I'm going to go to the left to -3 and down -1. What's another number I could plug in? 3. So 2 times 3 squared over 3 squared minus 25. So again, this would be 18 over -16, which again would be -1-ish. So I plugged in +3 and got -1. So I'm going to go to the right 3 and down a little bit past -1. So once we have a couple points there, we can draw our graph. As we get closer to the asymptote, we're going to get closer to infinity. Or as we get closer to negative infinity, we get closer to the asymptote. So our graph looks like this. Remember, in the middle, we can sometimes cross the horizontal asymptote. So sometimes you'll have like a point down here and another one up here. Then your graph kind of may look like an x cubed graph. So that is possible. It is possible to cross the horizontal asymptote when you're close to 0. But here we do not. Any questions on how we found that part? Are we done? No. I got to figure out what the left side's doing. So what's a number I could plug in on the left? Negative 6. So I have 2 times negative 6 squared over negative 6 squared minus 25, which this would give us 72 over 11, which we already found was 6.5-ish. So I plugged in negative 6 and got 6.5. So I'm going to go to the left to negative 6 and up 6.5. And then we can plug in one more number on the left just to be sure. What's another number we could plug in? Sure, negative 8. So this would be 2 times 64, which is 128 over 64 minus 25, which we said earlier was 39, which we said was positive 3-ish. So we plugged in negative 8 and got 3 something. So I'm going to go to the left to negative 8 and up 3-ish. So I know my graph is going to hug the upper left-hand corner up here. So that would be my graph.